Hi, IB biology students again. I just wanted to go through with you so that we don't have to spend as much time on it in class about the difference between chi-square tests and t-tests. Keep in mind that I am not a math teacher, so I'm definitely not an expert on these things, but I tried to give you the main differences that matter for you going into the IB biology exam. Feel free to ask your math teacher, not me, if you have lots of really detailed questions, because they would be a lot more helpful than I would be. So here we go. So, why would you possibly get these tests confused? What do they both have in common? So they used to find the difference between two and sometimes more sets of data. So you're trying to find out, is there a significant difference between these sets of information? So like wet versus dry, or if you are doing it for genetics, that's a common place that they do it in biology. Is there a difference? Does this fit the 3/4 ratio that we expected for the Punnett square? Both tests require a null hypothesis, aka there is not a significant difference between these sets of data. And both require you to use those charts with probability equal to 0.05, and they require you to find the degrees of freedom. We're going to see that the way that you find those degrees of freedom, though, is different. So this slide shows you what goes on with chi-square tests only, keeping in mind that they're both statistical tests that are used to determine if there's a significant difference between two or sometimes more sets of data. So imagine this being a big Venn diagram, and this is what would be only chi-square test. So the formula is easier, aka it's something theoretically, if you were given easy numbers, you could do by hand. Obviously, most of the time you do it in your calculator, but it's a formula that's reasonable to know and understand. Just O minus E squared divided by E, and you add them all up. You have an expected frequency. That's one of the biggest things about chi-square that you do not ever have with t-tests. AKA, you know that you're supposed to have 50% of this and 50% of that. If you're talking about the isopod lab, you would expect half them to be on one side, half them to be on the other side. If, say, we're doing a Punnett square, maybe you expected 3/4 green and 1/4 yellow peas. Other difference that we'll see from t-test, the way that you calculate your degrees of freedom. This was the thing that in class everyone got confused on. Then I looked back and I gave you the wrong answer when originally I gave you the right answer. So the number of variations of the independent variable minus 1. Now, that does not mean your sample size. How many data points do you have? No. How many variations of the independent variable? Think about IB grading for the IAs. Usually the number of variations you need is 5, right? But in some labs you may only have 2 variations, like in the isopod lab. So keep those ideas in mind, and then we're going to talk about t-tests. So here we have the t-test. It requires calculator or Excel to do math to figure out the value for t. Exciting news! On the IB exam, they'll give you the t value and just say, hey, look at this chart. Tell me if t is greater than CV or not. So don't freak out about having to do it on your calculator or using Excel. As far as I know, they're giving you the t-value, so that's exciting. And degrees of freedom, how do you find it? The total number of data points, aka, say you're doing a 5x5, so you have 25 data points, then you subtract 2 from that number, and you would get 23 in that instance. So that would be your degrees of freedom. So it's the number of data points, not the number of variations on the independent variable. Also important, you don't have an expected value. You don't know what you're possibly going to get. Think about all those IAs that you go into and you're like, oh yeah, I'm just seeing what happens at 10% bleach solution versus 20%. You don't know how many bacteria you expect to grow. You don't have a numerical value for that. So t-test, you don't have an expected value. Chi-square test, you do. So once again, this magical chi-square test equation that you need. Much easier than the t-test. These tests, you're also going to use different tables. They will always give you said tables, so that's exciting. They're not going to give you both of the tables and make sure that you remember which one's which. For the chi-square test, if you're doing 2 variations, your critical value is always going to be 3.84, so that's a pretty easy number to remember. You don't have to memorize it, but just FYI. So, I really, really, really want you to know the difference between these 2 tests for your IB exam, because right now we're just happening to be doing it. So why don't we take 10 to 15 minutes to re-bring back that information in your head, because you're already thinking about it for your isopod behavior lab. And please do these practice problems. So they're doing a blood drive, they get a certain number of donors of each type, they expect a certain percentage of each. But they don't actually give you the number of each that they expect. How do you figure that out? You have the percentages, you know how many people total there were. So you just take the percentage, convert it to a decimal, and then multiply it by the total number of participants. You would have had to add those up. So then you get what your expected frequency is for that. Your observed you already had in the previous problem. So then you're just going to do some math. Please do the math before you go on to the next slide. Then you should get your chi-squared to be, you add them all up, 24.844. That is chi-squared. You compare that to the critical value. Chi-square is greater than the critical value. Therefore, you reject your null hypothesis, which means, think about it, you're rejecting the no. So there is a significant difference between your data. The blood types that you saw were not exactly the ratios that you expect in a given population. Hooray, that's chi-square. Now we're going to do t-tests. So here's a chart for t-tests. Your degrees of freedom can completely vary. They happen to go up in a random amount in this one. Don't worry about the fact they go up by even numbers and then they start skipping by 10. Just notice that it's a different table than it would be for chi-square. Once again, I really, really want you to do these problems out. Fun fact, they already give you t in there. It's 2.02. So all you have to do is literally read the chart. They've even highlighted the correct column for you. So literally, this is ridiculously simple for your life. Just remember how to calculate degrees of freedom, and that's it. Magical. Before you click to the next slide, I want you to figure out if you think there is a significant difference given this data set. There is no significant difference because the t-value is less than the critical value. Okay, so once again, to review. Both use defined difference, both require a null hypothesis, both require to use some sort of chart. Test, much harder mathematically. These are the ones that are more commonly going to appear on the IB exam, so you really need to understand, especially when you're giving a t-value, right, that they did most of the work there for you. That's the stuff that you all had questions and confusions on. When we did the problems in class and they gave you the t-value, you all were like, yeah, this is easy, whatever. So know how to do the easy version of the problems. That's what you're probably going to get in the IB test. Number of data points -2. You don't know what you're expecting. Squared, common for genetics problems. You have an expected frequency. The formula is super duper easy and not much math. It's basically just algebra. And degrees of freedom is number of variations of the independent variable -1. So hopefully that was helpful. Please make sure that you did those practice problems. I want you to come in on Tuesday not only with your worksheet packet done, but also with any underlying questions or final questions you have about chi-square versus t-test. I really want to make sure that we're all totally clear on this. This is a great time for us to review this topic in preparation for the IB exam, so that way we don't have to go back to it when we are reviewing for the exam. Fun fact, this will make you feel better about reviewing. I was just looking back through the statistics unit. You're all going to be like, oh my god, Miss Dempsey, this is the easiest thing ever, because it's all like, oh, how do I find the mean and the standard deviation? And we've done so many IAs that you're all just super confident in that, so you won't have to spend any time reviewing that. Once again, I hope you have a great snow day, and once again, please pass this information along to your IB biology friends, the work that you have to complete. Thank you so much. I'll see you on Tuesday. Bye.